Hi everyone. Thank you for joining this presentation. I want to make sure that you can actually see it. There you go. Sorry about that. I couldn't see my presentation. Perfect. For those of you who've seen my presentations before, this one will actually be a bit less technical than normal, such as my EMC presentation I gave at EDS in October. But I hope you enjoy it anyway. Thank you for joining. I want to start off though with telling you a story. Many years ago, someone very influential to me, who happened to be a rugby coach, taught me something that changed the way I project managed throughout my entire career. Now you see, an engineering company or a technology company is actually quite similar to a rugby team, for those of you who know the sport quite well. In a technology company, you have a manager or someone overseeing a project, and then you have these type of niche individuals or departments that have their own technical skill. So whether it's the software engineers, mechanical engineers, quality engineers, etc., PCB design engineers. And in a rugby team, you actually have something similar, where you have a coach or a manager with an idea of how the entire team's working, and then then you have certain players with certain skills. So whether it's the backs who like to run fast and score the tries, you get the decision makers like the scrum halves, fly halves, loose forwards, which was people like me who run all over the pitch and try and do everything and do lots of tackling and support play. And then you get these players who are the stereotypical rugby player that you would see, which are the props, the bigger guys that you see in the team. And they do this certain type of part of play, which is called a scrum, like you see here. And in fact, the bigger guys are the ones at the front. Now, at this time, when I was speaking to this gentleman, as I was saying, I happened to be coaching a youth team. And at the same time, I was playing for a National 2 side, which was called Isha. And I went to the head coach, and this is him, and he's a Canadian international in the past as well. Now, I don't have any history in coaching this position or playing this position at all. So I went over to him and I asked him, and I said, have you got any tips or anything you could help me with in order to coach this position? And he said, Robert, don't you get it? You need to ask. And he pointed me and opened his hand towards the senior players who, say, 40 years old or more, who played this position, the big guys who were in the team at the time. And he said, just go over to them and ask them and see if they were interested to come and coach. I went over to them and they were more than happy to come down, and actually they coached 2 sessions during the entire season, just 40 minutes at a time. And during that, the team learnt more about scrummaging, about this specific method of playing than I could have possibly achieved in seasons, because I just wasn't an expert myself. And this is very similar to application engineers when you have a technology company. It's where you'll have people with niche knowledge, people who are dealing with this type of specific product or specific application every single day. They can come into your team, into your company, almost join just for a short amount of time, then help you out, and then they can drop out and basically use their expertise that they have. So basically, application engineers are pretty much like those big props, those older guys who came down and helped me several years ago to coach this youth team. Anyway, moving on to what we're going to talk about today. Probably quite a lot of this is obvious because it's so popular about what's going on in the news at the moment. I'm going to give a sort of time frame here, try and give it a bit of context of what's going on. But in my day-to-day role as an application engineer for electromechanical devices and connectors and sensors, we are constantly getting people looking for components now, in this moment in time. They're desperate for it because of certain things that are going on in the world. So if, say, someone was to place an order today, it is not out of the question that the lead times from the suppliers are over a year. Orders are getting pushed out. It is ridiculous. And there's not a lot that we can do at that point in time once they need to have that specific part. And actually some suppliers are now refusing to take orders. You're actually saying, right, there's this part I want, please go and manufacture it, please supply it. However, they're saying, you know what, we can't even promise to deliver it anytime. We can't guarantee we can actually deliver this because of all the reasons I'm about to say, or several of them. So they're just not even taking orders. This is terrible what's going on at the moment, and several reasons of it. So potential reasons for it. COVID is the obvious one, the C word, I had to use it, sorry, this early in the presentation. Reasons is obviously, so companies were shut, you know, up to the last couple of years ago. People were furloughed. Basically, companies were not working, so there would have been a backlog from it. But then also the opening up from it. Certain companies didn't even close. Certain companies opened and then went full steam ahead, 100 miles per hour, as soon as they got back to the office or got back into the working world. And other companies sort of stayed shut. So that imbalance also caused a type of shortage that was there. People were still isolating. I know we're sort of coming out of that now. I say that. I think in China, there's currently a lockdown going on now. And so, for example, I heard that in California, in a port that's there, there's actually ships, or were ships that are actually just off the coast, and they were unable to dock to unload their equipment because there wasn't enough staff in the port to actually unload it, because so many of them were so many of them were isolating because they had COVID. Other reasons, obviously, this Russian-Ukrainian war is going on now, which isn't helping things. Also, new market demands. And by that, I mean, when you have, so for example, electric vehicles, that is one of the big growth markets at the moment. But that then has put pressure on, you know, the smart devices inside the electric vehicles, for example, and other parts of automotive. That's then put a demand on the chips, which is obviously very famous, but also everything to do with the battery technology. As markets evolve, sometimes it takes a while for the supply chain to actually catch up on it, and that's also not helping with the situation. There's a reliance on something called just-in-time, which, for those of you unaware what it means, the whole idea of it is, so if you have a factory line, it's not helpful to have too much of your inventory needed for the factory line, because then you'd have to warehouse it. So it's helpful that it gets delivered just in time for when you need to start the manufacture of it. It's a really useful way and efficient way of working. However, if there is any shortage, if there is any problem in getting even one of these components on your factory line, therefore the whole thing goes wrong and it doesn't work. By not having this sort of backlog, by not having enough of a buffer there in order to solve this problem. That's another reason why, alongside all the other problems I've just mentioned, it sort of amplified it. And obviously, there's several more things as well that we could discuss. Now we're going to give it a bit of context. So there's a bit of background. Now, how does this relate to ourselves for you that are on this? I'm talking about design engineers. There's probably a couple of procurement managers on here as well that are talking. But when we're talking about your work and about launching a project, the key questions that need to be thought of at the start of the project is, when do you need the stock? Not only for production, when you actually physically need those parts, but also something else that sometimes gets forgotten about is for prototypes. And we're going to talk about this with more of a context now, but that's a key thing for us to understand in order to help out solving this type of problem. So let's, here is an example of where day to day, probably today I've got a few emails in my inbox at the moment and I'm shadowing my other colleagues who are helping to quote customers. And it's really typical that we will see lead times, anything like this. Let's say that order's placed today. Some of the parts are stocked. Brilliant, no problems at all. Other parts take about a 4-week manufacturing time. Glen Air is a perfect example of that I'll talk about later on, a real key supplier of ours. Then it's not out of the question that I see quotes, and then you get things around about 26 weeks, 12 weeks, 30 weeks, something mid-range, something that, ooh, okay, that means I really have to plan ahead. That type of thinking where, okay, this isn't going to be here soon. I really need to start organizing myself if that's the case. But then, as I mentioned earlier on, it's not out of the question that you'll see these delays going out months and months and months and just unable to fulfill what is required. Now let's give that some context, that lead time issue with regards to a project. What I'm about to explain is, maybe it's formalized within the company you work for, or maybe it's a bit rough around the edges how you do it, and that will depend on the organization of it. When we have a project, any type of project pretty much that I can think of that will later on go into production, there'll be some type of concept phase, something at the start. You could be in a bar with your friends, with your colleagues, talking about, hey, we should build this new widget. A whiteboarding scenario, it could be on the back of a cigarette packet, you could be writing your notes, something where you've dreamt up an idea of, hey, this would be useful for the market. It then goes into development. It creates a formalized project that is going to be manufactured, and you'll start getting a real good idea of what it's going to look like. Then at some point, there will be some testing. After you've made your device, okay, now we're going to actually test it. Can it do what it's meant to be doing? Is it on the same track? Then there'll be some type of redevelopment after it. And as I said, these can be formalized stages in certain dates where you have to comply by. I used to work for Sony in the TV department for them, and we had that. We had these specific dates when things had to be completed when I was an RF engineer. Otherwise, the entire project would be put back. Then after this redevelopment, you can do this testing again, and you can have a certain amount of stages that go with it. Then there'll be the type of formalized testing. And this will be, right, functionally, does it do everything that is required? And also the environmental tests. So these are things such as the EMC testing, things like environmental testing, temperature testing, vibration testing. Is the product going to survive in the real world according to the specs that it needs? Is it going to interfere with other products that are out there in the market already? Then the procurement stage, what we're going to focus on today. We're actually, okay, it's being tested, we're happy with it, it's being designed, now someone actually has to buy all of these parts, ready for the stage of production. And then the part that many people actually forget about is actually to deliver it to the market. So whether it's to your individual customer that you've designed something customized for, or just to put it out in the shop window there, just in order to get it out there to say, hey, it's available now to buy. And problems that can happen. Or, sorry, I want to focus on this procurement part, as I said. Now, going back to that slide that I mentioned earlier on about those lead times, issues that even I'm facing, that I'm getting customers coming to us for. I've got procurement managers that are desperate, or subcontractors from procurement managers, or companies that are there helping procurement managers, desperate to try and get these components within that time frame that they had set out. And then they're getting lead times that are longer than they would have expected. And so therefore, this is then pushing the date out potentially, is therefore moving the production date out, and therefore you're annoying your customer. So that dream of that initial concept, that cup of coffee that you had when you were doing a whiteboard about this thing I'm going to make, it's going to be really useful to the customer, it's ended in annoyance. And it's a shame when this happens. It's a real shame. So what can be done by the design engineering team up front during that concept phase and the redevelopment stage in order to help solve this? What can be done? Well, I'm going to go through several tips. That's my plan. There's 10 tips that I've got in the rest of this presentation. I'm going to go through this now. First of all, get help to review your bill of materials before it gets bought. In fact, as early on in the design phase as possible. I'm going to give a real world example of what happened with me. This is a connector from one of our suppliers called Harwin. And this specific customer had a problem with the lead time. This connector here, there are variants of it, and actually the specific one that was chosen had a type of tin lead plating on the pins. Now, historically, tin lead is used because if you, without the lead in the within the component, tin whiskers can occur. However, there's other technology that's used, such as a nickel undercoat, in order to protect that from happening. However, on this device that was being constructed by this customer who was looking for this part, there were other connectors that did not have this plating. Therefore, this component was chosen with no technical advantage. There was no reason that they had chosen it. It was simply either by mistake or because it was a part that had been used and it was on a database that I'll tell you earlier, that I'll explain later on. As you can see, it's a tin lead finish, and I can tell you by just glancing at this, I know that because it ends in 22, I know that's the lead finish. Why? Because I've dealt with this type of connector for years. It's just a quick glance. That's not obvious for people who do not deal with this type of component very often. And actually, because it's not a very common part, actually, it had a real long lead time. It was expected that it would be in stock, ready to buy, or a few weeks lead time, and actually it was 14 weeks. This actually held up the production, and it was a shame because all they would have had to do is at the design phase was switch it to an exact drop-in replacement, same fit, same form, same function, did absolutely everything the same, but to a different plating. So if they'd switched this part number to the 42, which is actually gold on the contacts and tin on the solder tails, this entire problem would not have existed. And it was a real shame, and there's stock available of this part. So it was a shame that this happens. And this could have been eradicated from just a very quick glance from someone like me who knew this type of connector. And as you can see, there's stock available. It's just literally the plating that is different on this, which wouldn't have made a technical advantage difference to them. But what if it's on a parts database? What if a customer is limited, or a design engineer is limited to choosing only certain parts that are on a list? And this happens quite often, especially in larger companies. The reason that you wouldn't want to do it is because larger companies do not want engineers just going out and finding whatever components that they want. They want it to be quite restricted so that they can control to make sure that the parts are legitimate, they're from reputable suppliers, and it is of the quality that's required. What I can suggest is, because of what FAEs or application engineers are able to do, because we deal with this every single day, we're able to easily provide all of the drawings, all the test reports, all the certifications, everything that you need, the weight, the packaging, and the dimensions, early on, very quickly, in order to solve this. I know it'll be a pain to do it. I know it's an added bit of work to do early on in the project. And I know that you'll probably be busy and you just want to use that same product that was already on your parts database. You've assumed it's readily available. No problem, I completely understand it. But at least let's try and do this up front, because doing this type of work is likely to be so much quicker than the headaches it could be causing further down the line, and hence delaying your project going to the market. And then onto that, if you are going to work with application engineers, and I'm not talking about just people in my realm, I'm on about FPGA application engineers. I'm on about people who are dealing with sensors, people who are dealing with all types of application engineering out there. We're all here and we want to help. We love our careers because of that chance of us going in and helping out your companies. Tell us those dates. Tell us when your project's going to happen, because then that gives us an idea of what type of solution we could propose. There's no point in us suggesting a technical solution that's great for your project if it's not going to be available for you when you actually need to place the order. It's pointless. If it's going to take 6 months for something to develop and you've got to manufacture your product in 4 months, what's the point? Yet knowing these type of timelines is going to really help point you in the correct direction of where to select the correct solution. Also, if you tell us those dates, we can actually babysit orders for you. So there's 2 types of order that basically a manufacturer gets. One is from a distributor, similar to Powell Electronics, where we have a large warehouse. It's useful to have lots of stock on our shelves ready for design engineers like yourself to quickly order something. It's in stock, that's great. But then also there are others which more of that just-in-time type of activity, as I was talking about, people who are actually requiring the parts for manufacture. That's where we can sort of pull some strings with the manufacturers that we know and like, hey, is there a chance you could put this one ahead of the queue to make sure that the customer doesn't go on a line stop? It would be useful if that was put ahead of the stuff that's literally just going to go on the shelf. Manufacturers understand that. They don't want to cause problems either, so hence they are usually happy to try and help with this. But the key is communicating this. Step 4, select the components, and I sort of touched on this a second ago. Not only to technically solving the design problem, as I mentioned, we have to choose it according to the project dates, but also something else as well that could really help. This is less of shortages, it's just not something I really wanted to include in this presentation, is a word that I've made up called manufacturability. I hope it's a word, sorry if not, but I hope you get the idea. It's how something's actually physically going to be put together. So if us design engineers at the start are going to be thinking about helping out the procurement manager later on down the project, What about helping the people who are actually going to assemble it together? Sometimes you have choices on, say, types of enclosures, I'm focusing on connectors because that's what I deal with every day. Sometimes it's the polarization of how things are actually put together. Sometimes it's actually the form or the size or the type of material that's used. That therefore just helps speed up that manufacturing process. Could be the type of screw that's chosen. If you choose a Phillips screwdriver or a socket screwdriver head instead of just a slotted one, it's easier for it to put together. You can actually speed up the process for later on in the production, which can really help. So take that into account at the same time, and that's what we try and do as application engineers. How is it actually going to be put together? And all you need to do, as I mentioned, is ask for help. Tip 5. The other thing as well, try and be supplier agnostic. Certain suppliers are more receptive than others. I completely agree with that. However, when you're at the early stages in a project, just try and think what is the best solution, both technically and commercially for it. I hear of certain engineers that I work with, they already are looking at what's in stock and trying to design around that, which is great. However, I will say be careful with doing that, because when you're choosing something that's just in stock, there's nothing to stop another company from just swallowing up that stock as well. That's just something to keep in mind. But very much try not to be limited too much by it. And I talk about this in a minute when it comes to cross-references as well. I'm going to compare two suppliers here so you get an idea of how they work differently. Glenair, really receptive supplier. I really like working with them. In fact, Powell is the biggest distributor of Glenair's products. They have a vast range of different solutions. I love it. And they're very able to customize and choose certain variants for an enormous range of applications. And then you've got Harwin, who I actually used to work for, and they have a limited, lower amount of products, and that's fine. Both companies are very good, they're very receptive, and I'm happy with the quality of these products when I'm suggesting them to engineers. However, they have different business models, and the reason I'm pointing this out is when you're choosing a component, try and work with how the suppliers are working rather than against them. Try and take advantage of the way that they are set up in order to support you. So if you have Glenair, they have fairly healthy stock in the market that they're able to call upon. But Harwin have a lot bigger amount of stock for what they have of the popular type of variants. They like to get lots of stock there out into the market. In fact, Harwin barely sell anything direct. I know that for a fact, because they want to use distribution. They like to get things onto the shelf, and that's why they push out lots of their popular products and try and use lots of the same stuff, the same solutions for different customers that I'll touch on now. Customization, the variation of their products, that is something that Glenair actually specialize in. That's why they have such a short lead time of only about 4 weeks on the vast majority of their products. If they're stocked, it's even quicker, but pretty much any variant of something you can choose, they can pretty much turn it around in 4 weeks, which is fantastic. Harwin, they steer clear of the customization. That's what they don't like doing, but they very much like to say, hey, we have many solutions that are available and they're stocked in the market. Please try those first, because we really think that will be the best way of you going forward. Hence lead times, as I said, Glenair is a very short lead time because that's their business model. Harwin, if you're looking for larger volumes that aren't there already in the market, it's about 2 to 4 months. It's fairly, standard for that type of product that's in the market. That's very typical. But as I said, for that short amount, when you're looking just for the prototypes, that's very good for them because you have it in stock. And hence prices, I will say, Glenair, if you want it in low quantities, it is quite expensive, because the majority of the cost of manufacturing, not the majority, but a huge cost of actually manufacturing something is actually the setting things up, the quality, making sure that the device is being produced to the standard that's required. And hence, if you add a larger quantity to it, that's why it actually gets cheaper. However, with Glenair, if you start getting to a higher quantity, say of 100 pieces or more, that's where it starts getting competitive with their competitors in the market. Yet Harwin, because they're producing lots of the same stuff, actually they're very price competitive for the type of solution that they're doing because of that. And that's why Harwin is actually distributors like Powell is able to invest a lot in the stock of Harwin products in lots of different variations because of exactly those reasons. We want to work with these suppliers in the way that they are set up for. Next, keep your BOM flexible. Your bill of materials, try and keep it flexible. This is what I was mentioning earlier on. And this is a hard slide to discuss actually at the moment. So traceability, okay, it's an ISO requirement. It is what's needed. I used to work for two different engineering companies. One was Sony and one was for a smaller manufacturer. And in both of them, of course, traceability is just as important. The idea of traceability is if something goes wrong with a product at whatever stage it is, there is a way of tracing it back through batch numbers in order to find out what exactly went wrong through the supplier, through the part number, and it completely makes sense to do that. And then because of this, it resulted in that standard parts list, as I mentioned earlier on. It makes sense, right? If we're going to buy this type of component, we're going to take this part. Completely makes sense. I entirely understand why you would do that. However, by sort of reducing the amount of options that you have available, it means then it's limiting your options to take advantage of what's in the market later on. It's not giving you the opportunity to get out of jail if you are having problems with shortages and supplying later on because you're being restricted. Hence, you're limiting your opportunity for alternative, either technical solutions that will do the same thing but look completely different, or just cross-referencing, which is a shame when I see procurement managers desperately reaching out for a certain component by a certain manufacturer. And I know that there is an alternative which either is exactly the same, fit, form and function, drop-in replacement, or extremely similar that would do the same job that could be supplied where there's stock. However, because it's been designed in, because it's gone through the testing vigorously, it's too far down the chain, it's been put officially on that bill of materials, it is not possible for them to change it. Hence, part of what I was mentioning earlier on about reviewing the BOM, can it be switched during development stage to something that's going to be more readily available or something with a shorter lead time, or during that redevelopment stage? Because to try and alter it during that production and procurement stage, it is very difficult. It's a shame when it happens, and it breaks my heart when I can see there's things that could have happened, and then it's causing these huge headaches, and then hence everyone further down the chain is suffering, and then the great hard work from the design teams is not then being rewarded because of something that could have changed. Linking on to that, try and not stick to the status quo. So that means it's very easy, if there's something you've used the year before, to use the same thing. Completely understandable. We're all the same with that. Even when I purchase things, I want to keep to the same supplier, buy the same thing. It's human nature to try and do it. However, if you think, and this is, I've heard specifically say for memory chips, I went for another seminar about this several years ago now, memory chip manufacturers. Because you have people who are just using the same chip every year, it's just a memory chip. That's all I want. I'll just use the same one. And then that means they're stuck to the same packaging of the memory chip. And then the PCB designer has designed their board around the same packaging of this. Every year they've used the same one. And then 10 years down the line, just by using the same one, because it's just a memory chip, I'll just use that. Then it means the manufacturer has wanted to move the technology on. They've wanted to actually use the newer technology to make it smaller, lighter, cheaper. However, because the design engineers have stuck to just using the same thing, quite rightly, it's human nature. I'm not having a go at anyone for it. It's normal that this would happen. It means that it's causing supply problems later on. And this is why you end up getting sometimes companies that will have purchased huge amounts of these products in the past, then 10 years down the line, no longer can find these parts. They'll be one of the only people who are actually still buying it. And hence it goes obsolescence issues that it goes through. They have to go through other companies about finding obsolete parts. It just causes a huge headache. And as I said, just have a double think. If you're using something the year before, just have a quick glance. Is there something slightly better that could be used? Is there a newer model that's been launched by the supplier? If so, just consider using that instead. Tip 8. And this is sort of what I said about helping out with that just-in-time information earlier on. So make use of the distributors' warehouses. Something that we do that helps out a lot of companies. They place an order for the MOQ or for a large order. That means that they take advantage of the price, the volume pricing, of course. But it means that, hey, they don't want to be delivered this entire whack of products because they've got nowhere to warehouse them. Fair dues. So they asked, hey, could this be delivered every month or every 2 months or something like that? And it's completely understandable why someone would do that. And that's something we can really help with. And that's just part of the communication, as I was saying before, just get in contact and then say, hey, when you're purchasing this, please deliver in X amount of drops instead, something we're more than happy to do. And actually, in some cases, Harwin is one example of it. If you're thinking about using something, if it's designed in, but you're pretty sure you're going to use it, but you're not entirely certain, get in touch, because maybe it's something that we could actually hold stock of. We could invest in that product if it's the right product and supplier that we're working with. Hey, we could even look at taking some stock of that to try and help you out, because if you don't end up purchasing it, if it's the right product, it's worth taking the risk, as someone else might buy it later on down the line. Just get in contact with us. Tip 9, use common solutions. I love this, and I love it when I speak to engineering companies that actually have already got this in their idea. So they're trying to solve a certain design problem, but then also they're trying to, whatever widget or makeup of this design problem they're trying to fix, they're thinking, right, we're going to try and use this down the line and try and make this into a separate module that can be used in multiple different projects. I love it. That is a really great way of working. It then helps with your volume of sales, with your volume pricing, which makes it cheaper. It makes it very easy for the distribution manager, and it saves a lot of engineering time. And one example is from one of our suppliers here, is KC. So if you look here, they're a backshell manufacturer. If you can see on the red arrows here, the cables you can see are different sizes, but the backshells you can see with the purple arrows are actually the same size. And what they've done is they use this wrapping braid around it and a heat shrink boot around it. They're specialized in this. And then they're actually able to supply the same backshell, which means there'll be cheaper pricing, which means it'll be easier to procure. It just helps out everyone down the chain. I think it's a very innovative way of trying to help out procurement. And if there's space on the board, if technically it's feasible that they can do that, if it's space on the end device, it's a fantastic way to go. And tip 10, try and reduce the number of items on the bill of materials. And by this, I mean, instead of, for example, purchasing, I'm sorry to focus on connectors, but it's just what I deal with every day. Instead of buying the connector and the pins and the wire and the boot and the everything that goes with it, reach out and see if the entire cable assembly could be supplied instead. Move that burden of chasing up all those individual suppliers, making sure you have that, move it on to a subcontractor or to a specialized distributor like ourselves that can do that. Or things can be kitted together. It's literally reducing the number of items on the bill of material to help out the purchasing manager later on. It's something that can really help. So as I mentioned, these are some of our technical partners. If application engineers like myself don't know the answer, we have first name terms with application engineers that reach out to the certain suppliers. This is the same for other application engineers in other parts of the industry as well. The FPGA application engineers, I've seen there's a few online on this EDS forum today. We all just want to help you. We're all here, and whether it's directly the manufacturer's application engineer, or it's people who help finding the right person, who have our own set of knowledge skills, the supplier agnostic people like myself, we really very much want to get that technical knowledge, that niche knowledge to yourselves. But then several months ago, Powell thought, could we add to this with all of the climate that's going on now? What else could we do to try and help with the shortages that's happening? Are there any other suppliers we could add to this? And we've actually come up with these 3 new ones that we've recently added, which I'll explain in a second. And also we've enhanced our relationship. The relationship was already amazing, but just on one specific product focused on Glen Eyre that I'll also talk to you about. And these are, and with each of these products, with each of these companies, their lead times are in weeks. They're not in years like some of the other potential suppliers are having for similar products. They're great at potentially being cross-references as well as their own solutions that can be used. So of course they can design something first principles with you, they can work about finding the correct technical solution, but they are very useful, these suppliers that we have, in order to find an alternative, hopefully earlier on in that stage, in your project cycle, as I said, or worst case scenario at the end when we're in that purchasing stage. KEC are a back shell manufacturer. Ultran are a contactor manufacturer, so that's those almost high-powered relays that are very popular in electric vehicles, for example, at the moment. One of those new markets that are having shortages, as I mentioned. HiG are a relay manufacturer that very recently we set up a partnership with them. It's been very successful with them in order to get some companies out of jail, basically, that would have had their production delayed, but actually we've got in there and we've solved their problem. And the other thing is heat shrink boots that Glen Air have. We've taken stock of them. We're then using their stock with a closer collaboration of it, exactly for solving those types of issues as well. So in summary, the conclusion, let's try and reduce the stress, especially for the procurement managers later on in the project cycle and the customers that are out there. If we do a little bit more of work at the start or during that project cycle, which, as I said, it's less work for yourselves, you just have to reach out to the right people who are more than happy to come in and help you. We are the rugby players that was like the people who helped me when I was younger, when I was coaching that youth team. That's what we are, and it would be an absolute pleasure for us to help you. Let's remove time pressures, let's get things organised, let's reduce that stress. Oh, thank you very much, everyone. So for all things connectors, electromechanicals and sensors, that's what I can personally help you out with. And these are my contact details. Find me on LinkedIn if you want. If you have any questions or want to talk to me about anything, feel free to reach out on this forum, because time is extremely short right now, this presentation. But feel free to reach out on this forum. We'll have a chat, or email me directly. And it would be, as I mentioned, an absolute pleasure to be helping you all.